When finding the zeros of a polynomial function, you need to use the rational zeros theorem and synthetic division. If you're not familiar with the rational zeros theorem, just look it back up and see how that works. I'm going to go over it fairly quickly here. Same thing with synthetic division. So for f of x equals x cubed minus 4x squared plus 4x minus 16, we need to find all the zeros of the polynomial. So the first thing we have to do is first find the possible zeros so we can figure out what are the actual zeros. And we know that since this is a cubed here, we can have at most 3 zeros, period. So first off, let's find all the possible zeros, all the possible rational zeros. And so we start off by taking the factors of 16, and we're going to get plus minus 1, plus minus 2, plus minus 4, plus minus 8, and plus minus 16. And we're going to divide all of these by the possible, or all the factors of 1, which is not going to change anything. So these are all our possible rational zeros. Now that we have this, we need to use synthetic division to figure out which ones are the actual zeros. And so set up my synthetic division. I have 1, negative 4, positive 4, and negative 16. Now I'm not going to go through all of them. I'm just going to go with the one that does work. In this case, 4, but you should try out some of them to see which some work and some don't. You can kind of simplify it down by just kind of removing, like the 16 is most likely not going to work, so I wouldn't try that first. But 4 is going to work, and I'll show you how it does. So we bring the 1 down and go through the synthetic division. 1 times 4 is 4. Negative 4 plus 4 is 0. And then do it again. 0 times 4 is 0. 4 plus 0 is 4. 4 times 4 is 16. Negative 16 and 16 is 0. So since the last number is a 0, 4 is one of our answers. So one of our zeros is going to be 4. And we can reduce this down as we start with a cube. This is going to be 1 less. So it's going to be 1x squared, no x term, and then a positive 4. So that's the remaining polynomial, and we're going to set it equal to 0. Now this is pretty easy to solve for since it just has one variable. So we can take it over here, x squared plus 4 equals 0, and we can solve. Subtract 4 over, x squared equals negative 4. Then take the square root of both sides, and we're going to get x equals plus or minus 2i. And again, this is positive 2i and negative 2i, which is the last 2 zeros. Even though they're complex, we just want the zeros. So whether real or not is not the point. We just want them all. So positive 2i and negative 2i. So these three are all the zeros of this polynomial function. Now we have 3x to the 4th plus 5x cubed plus 25x squared plus 45x minus 18. And again, we're going to have to use our rational zeros theorem to find all the possible rational zeros. So possible zeros. And I'm going to write out all the factors of 18, which is going to be plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, plus minus 18. And now I got to take all the factors of 3 and divide them by all of these terms. And some of them are going to repeat, and we're going to get not bothered doing that again. We just want the new ones. So we don't worry about the factor of 3, which is 1. Just throw that away. We're going to focus on just the other factor, which is a 3. So 1 divided by 3 is going to give us 1/3. So another possible zero is plus minus 1/3. Going to divide 2 by 3. We're going to get plus minus 2/3. 3 divided by 3 is 1, which you already have. 6 divided by 3 is 2, which you already have. 9 divided by 3 is 3, which you already have. And then 18 divided by 3 is 6. Again, we already have it. So we only have 2 more or 4 more zeros possible. So here are all of our possible zeros. And again, we're going to do synthetic division. So setting it up, 3, 5, 25, 45, and negative 18. And just like before, I'm not going to go through all of them because that'll take a while. So I'm just going to figure out which one I think works. And I'm going to say, because I've already done it, negative 2. So go through the synthetic division again, bring the 3 down. 3 times negative 2 is negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 2 is positive 2. 25 plus 2 is 27. 27 times negative 2 is negative 54. 45 and negative 54 is negative 9. Negative 9 and negative 2 is positive 18. Negative 18 and positive 18 is 0. So we have one of our zeros, which is negative 2. So x equals negative 2. And again, this is a degree 4, so there's up to 4 zeros. So rewrite our polynomial equation, because we start with x to the 4th. We're going to drop down to x to the 3rd. So 3x cubed minus x squared plus 27x minus 9 equals 0. And we can do synthetic division again, or we can look at this and we can see that this is factorable using factor by grouping because it's 4 terms. So I can factor out an x squared from the first 2 terms, which I will have x squared 3x minus 1. And I can factor out a 9 from the second 2 terms. So 9, 3x minus 1 equals 0. And when I factor this out, I can take out the 3x minus 1, and I'm going to have 3x minus 1, x squared plus 9 equals 0. And I can set each one of these individually equal to 0, and which is what I'm going to do. 3x minus 1 equals 0, and x squared plus 9 equals 0. So solving for the first one, add 1, divide by 3. 3x equals 1, and then x equals 1/3. So there's my second 0, which means that I could have used a positive 1/3 in synthetic division as well. And then I can subtract 9 over. X squared equals negative 9. Square root of both sides. X is going to equal plus or minus 3i. So I also have a positive 3i and a negative 3i. And these will be my zeros for the original polynomial function.